as we move on to 6-7, 6-7 is all about what we call inverse relations and functions. So you're going to be given a graph and you're going to have to know how to find the inverse of that graph and lots of things about their domain and range. We're going to just talk about the basics first today, and then tomorrow the video won't be quite as difficult if we have the basics down. Okay, the long and the short of it is the inverse just switches the x and the y values. That's it. You just switch x and y and you're done. That is the inverse of an equation or a graph or a chart. So, problem 1. What is the inverse? Now, look, over here I put, let's say you're given a set of points. How do you do it? What is the inverse of this relation? Well, of this relation S. They're calling this S, I guess. You literally just have to switch these x's and y's. So instead of 0, -1, -1, 0. Instead of 2, 0, 0, 2. Instead of 3, 2, 2, 3. And instead of 4, 3, 3, 4. You just switch your x's and your y's. Yes, it really is, for this type of problem, that easy. You'll have a homework problem just like this. Now it asks us to not only find the inverse of it, but to graph it so that you can see it. So 0, -1 is right here. 2, 0 is right here. 3, 2 is right here. And 1, 2, 3, 4, 3 is right here. We are not going to connect the points, and you don't need to let it bother you that those points do not make a straight line. That's not a big deal at all. Okay, you just have to plot the points the way they tell you to. And now what we're going to do is plot them on this one too. We'll plot the inverse. So this is the original, and this one's going to be the inverse. So -1, 0. Just switch your x's and your y's. 0, 2, 2, 3, 3, 4. And that's it. You can plot them both. I don't know why I didn't. You could plot them both on the same graph. That actually wouldn't be harmful at all. What you might not know or might not be able to see is if I made a perfect line like that, if I were, in fact, oh look, you can almost see it on the ruler, can't you? Take a look at the, that's kind of neat. Take a look at the shadow on the ruler. Can you see how it's literally like the shadow on the ruler is the exact same dots as those ones over there? Can you see that? So it is the inverse because it folds around this line. Can you see how the dots on the ruler, like kind of the image, the reflection, matches this original one over here? Okay, the domain of the original, if they ever ask for it, the domain are just the x values. So I'd write 0, 2, 3, 4. And you really should write them in braces. The range of the original, -1, 0, 2, 3. In order, least to greatest. We learned this in chapter 2. The domain of, oh, I'm so sorry guys, change this. Well, I'll change it before I print it. I want this to be inverse and this to be inverse. The domain of the inverse is the -1, 0, 2, 3. And the range of the inverse is 0, 2, 3, 4. My point of this is just to show you that the domain of the original matches the range of the inverse, and the range of the original matches the domain of the inverse. The x's and y's just switch. Okay, now we're going to do an inverse. So you're going to be given an equation, and you're going to be making a new equation. This one will be a little more difficult. So it says find the inverse by switching x and y and resolving the equation for the new y. So we used to have y equals x squared minus 1. This was the original. Now we're going to have x squared, x equals y squared minus 1. Notice the y just becomes an x and the x becomes a y. Now I do have to solve it for this y. So I'm going to add 1 to both sides. So I'm going to move over here so I don't run out of room. So I'm going to have x plus 1 equals y squared. Now to solve for this y, you learned in section 6.5 to take the square root of both sides. In section 6.5, when you take the square root, use plus and minus x plus 1, and that equals y. So that is your inverse equation. Okay. The original, I hope you know the original, which was just a quadratic, So the domain of the original, or the domain, is x equals all real numbers. It's a quadratic. The range of the original, now, this might, do you guys remember way back when we studied chapter 4, could you remember that the vertex on this was 0, -1? And if you can't, may I suggest that you pull out your chapter 4 stuff and just try to figure that out there in your 4-1 notes. So the vertex is 0, 1. So your range is going to be, because it opens up, y is greater than or equal to -1. Now, because you know these ones, you know this. I'll make sure this says inverse on yours. Because you know the domain and the range of the original, you just have to switch those for the domain and the range of the inverse. So the domain is x, but it's not all real numbers anymore. It takes on this quality of being greater than or equal to -1. These always have to match. The range of the inverse is y, but it takes on this quality, all real numbers. So you should see that the domain matches the range and the range matches the domain. Okay. Problem 3, time to learn how to graph these things, graphing an original and its inverse. So let's say we have y equals x squared minus 3, and I want you to graph both it and the inverse. Well, that means you need to remember your chapter 4 stuff, and you need to remember that this is a quadratic, and in order to graph quadratics, you have to have an XY chart. You put your vertex in the middle. Again, I hope that you remember your vertex in this problem is 0, -3. That comes from your chapter 4 skills. So you put 0, -3 in the middle, and you surround it with its corresponding numbers. Now you take these numbers, if you remember, and you plug them into your equation. So 1 squared minus 3 is -2. 2 squared minus 3 is 1. Again, I'm really hoping you remember how to plug numbers into an equation to get your y values. So this is the original. Now, since we had to make an XY chart to graph our original, the inverse, the XY, we may as well make an XY chart and just flip these numbers around. So all we have to do is flip. Since we already have an XY chart, we're not going to like resolve it like we did up here. It doesn't ask us for the new equation. It just asks us for the graph. So we're just going to, since we already made an XY chart, we're just going to make a new XY chart. So just write these y's on your way down. Oh, I don't know why. Those should have been +1. That top one, I should have made it a +1. I wasn't thinking very well. Okay? So let me rewind. I'm sorry. So we're going to flip those. So we're going to have +1, -2, -3, -2, 1. And then flip just to make your x's into your y's. Okay, I had to think about that for a sec to make sure I did it right. We're so used to the y being reflected, but in this case, since it's an inverse, the x side is going to be reflected. So let's graph the original. So left 2 and up 1. Left 2 and down 2, or left 1, down 2. I'm graphing the original. If you need to, pause the video so you can graph the original. Take your time now and plot the inverse. I'll plot it in blue. It's going to almost feel like you're not doing it right at first. And as everybody see the blue dots? The inverse is the same picture, but rotated 90 degrees. So the blue one is the inverse. Now, if I could, and I wish I could show you, if you could take your paper and fold it, these graphs would literally lie right on top of each other. I don't know if you can see that happening or not, but as I fold the paper, the graphs literally lie one right on top of the other. That is what an inverse is. The original, when you fold it on a diagonal, should end up folding right onto that inverse. All right, now we're going to do one more graphing one, but this time the graphing is going to be with y equals mx plus b's instead of with quadratics. Okay? Hopefully you'll find that a little bit easier. So if y equals negative 2x plus 4, or 5, and we're going to find its inverse. The original. I hope you remember that this is linear, which means it just makes a straight line. Guys, for straight lines, we don't use an xy chart. We just note kind of, okay, the y-intercept is 5. The slope is negative 2 over 1. You've been graphing straight lines since like 7th grade. So you're going to go to 5. And down 2, right 1, down 2, right 1. Until you have what you consider a pretty good graph, and that's your original. Okay? So this is not a parabola, which is why I am not making an XY chart. I don't need an XY chart for straight lines. I can graph a straight line without an XY chart. Now the inverse function. It's almost, in this one, since it's a linear function, I don't have an XY chart to flip, so what I'm going to do is instead of having y equals negative 2x plus 5, I'm going to switch my y into an x and my x into a y and just resolve the way I should know how to. Okay, so this is the original. Now I made my inverse. I'm going to minus 5 from both sides, so I have x minus 5 equals negative 2y. I'm going to divide everything by negative 2. Okay, remembering there's a 1 in front of your x, and that's going to give me negative 1/2 x plus 2.5, we did this in chapter 2, equals y. So now I have my y-intercept of positive 0.25. I have my slope of down 1 over 2. So I'm going to go up to 2.5, make my first y-intercept dot, just graph in a straight line. Then we're going to go down 1 over 2, down 1 over 2, down 1 over 2 until I feel like I have a decent graph. Connect. And if you ever want to double check just to see if you did it right, so this one's the inverse, I'll write that in blue. This one's the original. Okay, to double check, all I need to do is pick up my paper, fold it on a diagonal, and it should fold, if you did it right, it should fold right into itself. Let's see how I did. So you can see when as I fold it, they fold right into each other. I know I did it right if that happens. Okay, and those are the basics to get started with 2-7.